So welcome to Streamr. This webinar is meant to show you a brief overview of Streamr peer-to-peer network. We have here Eric, who's one of our senior engineers working on the Streamr stack.
Hello, everyone.
Hello, yeah. So what he'll be going through is he'll walk through like our network repositories and our GitHub, present a quick overview of the architecture of the network and some of the, I guess, design decisions that we made behind it. And then he would do a hands-on demo / example how you can run a broken node or network on your machine, local machine, and produce data to it. And then finally, we're open for Q&A if you have any. If during the presentation, if you have any questions, feel free to send us a chat. We will save those questions toward the end. Try to answer them as much as possible. With this, I will be switching over to Eric as the host.
Right. Yes, hello everyone. I'm Eric Andrews. I work as a software developer here at Streamr. Today, as Wei said, I'm going to be presenting network. Some of you probably know 2 weeks ago in Osaka, Japan, during DevCon there, we released the Corea network version. I'll go through that in some detail now. What I won't be going through is the core app and the marketplace app. They're kind of a separate topic, but I'll kind of drill into the network in this talk. Let's start with kind of going in. Oh yeah, one point. I don't know the audience, how technical you are, so I'll try to keep it somewhat on a general level. But if you have some more general questions or technical questions, I'll have the QA after presenting this stuff. So let me share the screen here. You now should be seeing my screen. Is that the case? I think so, yes. Most of our open source repositories are under GitHub, under the Streamr Dev user. You can find them here. The one very central to network is the network repository. It's located github.com/streamrdev/network. And this is kind of the main library of the network. It's written in Nodejs, and yeah, it's kind of contains most of the logic of how the peer-to-peer nodes kind of communicate with each other and register to the tracker, which is a separate entity I'll go more into soon. If you're interested in diving very deep, there's here instructions for running tests, developing, and that sort of stuff. One interesting thing, maybe if you're looking for a more broad overview of the network, is the wiki page. So when you go to github.com/streamr.network, there's the tab wiki. You click here, and you'll get kind of into explanations of some of the terminology we use in the Streamr network and kind of some concepts and kind of how they work. We have things like message propagation, which is one of the main things our network does, but also duplicate detection is very relevant to avoiding, to enable the network to scale, right? And we have a section on data persistence. It's kind of work in progress, but we try to keep it up to date as we develop the network. So under software architecture is probably an interesting place. The network is built out of these layers. And these layers allow us to make like different choices on different aspects of the software without having to rewrite everything when we make those decisions. So the connection layer is sort of the lowest level, and it's concerned with very low level networking details, like do we want to use TCP, micro TP, UDP, WebSockets, or whatever. Currently, we're working with WebSockets on the connection layer. The reasoning behind that is mostly because it's very familiar to us. It was a good starting point for the Corea network. We might go with some other choice later in the future, but at this point for the Corea, it was a natural choice there. Protocol layer is the Streamr protocol, the way the messages are formed and gives the meaning and semantics for those messages. It's defined at the protocol layer. We have the logic layer, which kind of contains most of the application level logic, how nodes propagate messages, how they register to the tracker, how the tracker forms the network topology and that sort of stuff. And if you want to go really deep, you can read more about it here. I'm not going to go that deep now here. The second repo, which is kind of alluded in this chart, is the broker repo, and that's the actual executable of the network. So this is the thing you actually run to run a network node, right? You can find this in Streamr dev/broker. And one of the things, it basically uses the network repository, which I previously showed as a library, and then kind of extends it with certain features. For example, it allows foreign protocols to be transformed into kind of network protocol. It makes it interoperable with, say, HTTP or MQTT. So we can do that in this broker layer. And it has support for long-term persistence currently with Apache Cassandra, but it's kind of made adaptable. So some other technology could also be used. Given that, yeah, a few other things I'll quickly show. Streamr client JavaScript. If you've ever worked with Streamr as a programmer, you've probably used this library. It will be familiar with you. Will be familiar with it. You can use this with the example I'm going to show. But what I'm going to opt to use is wait a minute. I have to move the window a bit. Yes, CLI tools. This is a very handy tool, Streamr dev/CLI tools. This is a very handy tool to quickly kind of in terminal to interact with Streamr. So what you can do with this is you can listen to streams, you can publish to streams, you can ask for resends and that sort of thing. You can generate random data. You can kind of operate with your stream. And I'm going to kind of use this in the demo instead of the Streamr UI, which you might be more familiar, which looks like this. With all the streams, canvases, and that sort of stuff. And yeah, I might as well jump into the demo now. I'll quickly check if there's anything interesting in the chat. QA, nothing at this point. Okay, I'll share my terminal then. You should now see a black terminal. Let's see, LS there, let's get it started. So what we're going to do now is I'm going to kind of show you how to run 3 nodes plus something we call the tracker node on your own machine. And to get this running on multiple machines, it's not much of a leap from here. Of course, you need to kind of deal with firewalls. That's kind of maybe the biggest thing you'll deal about, but kind of the same principles are somewhat applicable to that scenario as well. So one thing we have is this cool tool called Streamr Docker Dev. Actually, I'm gonna share the browser still for a moment because I forgot to show this. So this works on top of Docker, which allows you to run kind of arbitrary code in containers on your operating system. And you can use this to kind of set up the whole Streamr ecosystem, including the marketplace, the engine editor, the core, which we call the core, and basically everything with this. So I'm going to use this in this example. If you want to set this up yourself, you can do it. You install Docker Community Edition for Mac, or we have different instructions for Linux. It's quite straightforward, and you can kind of run the entire platform, the entire stack kind of quite easily. Let me share the terminal again. So what I'm going to do is I'm going to Streamr Docker Dev, start engine editor. This. And start engine and oh, okay, there we go. And it'll start up our services. You can see MySQL, Cassandra, Redis, So one thing why I kind of need to run this now is in our current system, we still use, in the Corea release, we still do sort of authentication of streams on the centralized backend. Of course, this will change in the subsequent releases. We will go to the more decentralized release. But right now, we kind of need this centralized database here. I'm going to do Streamr Docker dev stop broker node. So if I wanted to, I could just run this and I'd have the broker node already running, sort of the network with one node. But I want to kind of give you a better glimpse into that. So I'll stop it for now and kind of run it manually myself. And here we will sort of see, we have to wait a bit for everything to start up. I can do this log F to see how we're doing on that front. We can see Cassandra starting up, our engine editor, the core app starting up, key space initialized. All right. So the first thing for a network, the first thing that we need to do is we need to install the network library. And we will do it like this: npm install g Streamr network. So you need to have like Node.js and npm already installed. You'll run this command. It's found in a public repository. On my machine, it's probably already installed, so it will be quite fast compared to how it usually needs to install. It takes a bit more time, but you can see that now it installed it. And it gave us a few commands. We have tracker, and we have publisher, subscribe with storage, tracker with reporting. What I'm going to do is I'm going to run, after I install that, I get this command called tracker, which I can use to run a tracker. But I'm going to do it with this debug flag, which allows us to kind of see what is happening within the tracker. So it gives us more detail. So we can see that it's starting to listen on port 3300. And yeah, well, that's the first step. So now we have a tracker running. So what is this tracker? Well, the tracker is basically the current way in how these peer-to-peer nodes find each other. They have this tracker they connect to, they register there, and they ask for other nodes. And that's the way how they kind of interconnect and form the network. And the tracker makes sure that the topology is somewhat smart. So it's not like absolutely terrible. So basically that's what we have here now. I'll open another tab here and I'll do npm install g Streamr broker. So as I explained before, the broker is kind of the main executable for running a Streamr node. Let's run this thing. And it's running. With the broker, we have a version 504. Okay, that's good. With the broker, we need to kind of supply it with a configuration file, which our repository, if you go check it from GitHub, will provide you with some ready-made configs under the configs folder. If we want to have a look at what a configuration file basically consists of, it's we have the ID of a network node. So every network node needs to have like a unique ID that identifies it kind of in this more abstract notion. So you have an IP address on a port, but you can also have a more abstract identity, which we can, it makes sense to refer on a higher level on the software architecture to this name. So development node 1, host name, localhost. We have the port 3315. This is the port it will use to communicate with other nodes in the network. We have the tracker, which we're running, so it knows where to find it. We are saying that this is not a storage node, which is a special kind of node. I can get into that later. We're having Cassandra configured here. Porting, Sentry, we don't have that. And we have these adapters, which are now the way in which clients, so when you're using the Streamr client JavaScript or you're using the CLI tool, these are the ports you will be basically using. So there's 8890 for WebSocket, 8891 HTTP, and 9000 HTTP. So I'll run a broker by supplying it the path to the configuration file. And I'll run broker development end1. This, and we can see it's starting Cassandra, skipping reporting, using Streamr core in this URL. It's configured with the tracker, and now it's kind of reporting logs of how many messages are going in and out. Let's start a couple more brokers. So I'll use broker development 2end. So we have a second network node now running, and it will connect to the first network node. And they do it via the tracker, which I started kind of first. And let's still run a third broker node. So broker development 3end JSON. So what we now basically have is a 3-node peer-to-peer network running on my local machine, right? So the next step is basically to do something with it, right? Let's use it for something. So what I can do is I can install the CLI tools, which I mentioned earlier. Now, I could do this with the JavaScript library. I need to write some code to do that, but I'd preferably not run code for a demo. So I'll use this, which is a handy tool for testing out these streams and the functionality. So this is how you install it. npm install g at Streamr CLI tools. So it's a bit different. It has this npm organization tag here. You install this. And the CLI tool is just using the Streamr client JavaScript library basically in the background. So it's just kind of like this nifty way of kind of testing out streams. So you might be aware, I'll share my browser again here in Streamr URL. If you've used the product, you know you can create a stream and give it a name and whatever, test. So what I'm going to do here is just, I'm going to do this with the CLI tool just to save some time. So it's basically the same thing as me going through the UI and doing this, but do it this way. So right now I'm doing this on this kind of core app that's running on my computer. This is all happening sort of locally now. Streamr is the command for this CLI tool. And what I can see here is there's commands generate JSON data, listen to a stream, publish to a stream, list, show, create. What I'm going to do now is create a stream, right? Create. Okay, stream create. Okay, I need to give it a name and an API key. So I'll give tester1. I'll give it the name test stream. And I'll give, this is a often used authentication key for our local development environment only, so won't work in production, just in case you're wondering. And let me see this. I always get it wrong here. I need to use this dev flag. So now it was trying to create a key in production, but I want to do it in my development environment, so I need to use dev. Right. And it created a stream. So we have a brand new stream with that ID. Let's do now the following. Let's run Streamr listen. So we're subscribing and listening to a stream. This, and let's provide the key. So we have the stream ID, Streamr listen, the ID of the newly created stream, which was up here. And then we have the key. So now we're listening to this key. Except, yes, I need to have the dev thing again. And then now I need to give it a WebSocket URL to listen to. So it will be subscribing via WebSocket. Now, if you remember, we started 3 broker nodes before. I'll take one of these. Let's take this one, 8890. So that's the port where that broker node is running. And then I'll put it WS, localhost And I think in a future version, I want to make this a bit easier, but right now you have to kind of write this whole URL here. So it's kind of telling now the client where to subscribe, which node to subscribe to. And I'm choosing the first one I started here. Okay, that's good, but we're not seeing anything, right? Well, no one's producing data to the stream right now, so it's empty, right? So what we want to probably do now is open a new tab and have something produce data, but on a different node. So we see the sort of data propagating through the network. So let's split a vertical pane here. And this was the listening one on the left, and on the right one, I will now produce data. Now, I have written this handy thing here for generating data, like random data. This command generates random data. It's a good way to kind of test out something, right? So I'll do Streamr generate, and then pipe it into Streamr publish. So this supports these Unix pipes. So now what's going to happen is the Streamr generate command will produce random data, JSON form data every second, and it'll pipe it to the Streamr publish command. And for the publish command, I want to give it the same stream ID, which I just created, this, and tester1 API key, and the dev thing. And this time, let's copy paste this as well, but let's make it produce for to be a somewhat interesting example. Let's choose another node. So let's choose the third node we started, 8894. Now, if things work, we're going to start seeing data on the left side. So now data is basically propagating in the network. There's one stream, there's 3 nodes, one stream, one client is producing data to one broker node that gets propagated to the 2 other ones, and the other one has a listener here. So that's basically it for the demo side. Another command you can do is you can do, if you want, interested in like, what are the last 10 messages, you can do Streamr recent last 10. Okay. Play around with this tool and get some data. Yeah, that's about it for the demo part. Some things like just other kind of what in a typical deployment scenario, of course, you're not running all of this on a single machine, right? You want to run it on multiple machines. We have some of these environments running. The challenge with them is typically the firewall thing. So right now, at this point, the Corea network doesn't still have these NAT traversal things, but they're coming in future versions. So it'll be much easier to set up a multi-node scenario. But the main challenge comes with firewalls generally. Also in near future, running more of this stuff in Docker images. We already have a Docker image actually for the broker. So we've already Dockerized that. So you don't need to install Node on all these machines. You just have Docker, or you have a Docker compatible environment and you run an image there. Yeah, that's about it for me. Now maybe for the questions, it was a bit maybe technical, but hopefully you got something out of it. If you're a non-technical person, if you're a technical person, you probably saw how to sort of run our environment. Yep. Any questions? Okay, so once data is put into, once data is put in the Streamr network, is it guaranteed to reach its destination? That's a good question. I would say with the small network node, the small network, it wouldn't be so reliable necessarily because we would only have sort of 3 nodes, so it would be really easy to knock them all down or a few of them down. What happens is when you publish data into one node, it will propagate it to other nodes that are listening or who are subscribed to that stream. So in the Streamr network, we never publish data to every single node in the network, right? If let's say we have a network of 1,000 nodes, if I push a data, it doesn't get propagated to 1,000 nodes, it gets propagated to a subset of those nodes. And I guess the guarantee here is that if the subset has to be made sort of large enough for it to be kind of reliable and not be knocked off. So I would say, yes, it is guaranteed if there are enough nodes kind of configured in that partition. How long is data stored for in the network? Okay, so data is stored. So in this demo, I didn't actually show you sort of the resend thing. There is, I can quickly maybe share the screen here. In this configuration, we can kind of give this is storage node. We can set this to be true, and then it becomes basically a storage node in the network. Regarding your question, how long will it be stored? That's the setting of the stream currently. So the stream can be set to sort of, you can set it to like 30 days. You can set it off if you want. You can set it for a very long time. I guess the main question with that will become, as you might know, in the Corea network, we still don't have the incentivization. That comes in a later version. So we kind of need to think about what's the proper way of incentivizing them. So there's maybe some kind of like renting of data. So you pay for it to be stored, because otherwise basically everyone will be like, hey, unlimited time, please store all my data. And that's just not feasible. So it will probably be a setting of the stream, and it's somehow then paid by either by the producer or the consumers of that data. That would be the model, something along those lines. With the guarantees in your previous question, I wanted to just add something there, that these storage nodes are also there to sort of make sure that the data gets guaranteed delivery. So even if a node kind of for some reason misses a message, it will, via the storage node, via these resend requests, it can do this kind of gap request. Like it can detect it's missing some messages and send a request to a storage node, and the storage node will have that data. The storage nodes are built in a way that they cover all the streams. So basically, there should be an answer. Yeah. Yeah, there's another question here. Wei asks, how are we handling or plan to handle node discovery and efficient routing? That's interesting. Yeah, so node discovery, we currently have the tracker, as you know, in the network, which I kind of showed you. Let's just have a look at it just for concreteness. We have some logging here, but yeah, basically make sure that the nodes find each other. Let's do this. Let's close it and let's restart it. We can see that we'll start sending these instructions to each other nodes up here. So getting back to the question, yeah, how are we handling discovery? So there's been two models we've been thinking about, and this is tracker node. The thing about the tracker node is, of course, it requires some trust. You need to kind of trust the tracker. There are ways to make it more trustless, but it is kind of like this software that's running there, and yeah, you need to trust it to find, to not basically cheat or that sort of stuff. The good thing with the tracker node is that it has a global overview of the network. So it can make it really efficient with respect to latency, right? It can kind of, it has the best knowledge of the kind of network, the global network at any given point in time, whereas a single node will basically only have accurate information about its neighborhood, the nodes near it. Another model we could use instead of a tracker is to have this kind of approach where these nodes themselves, maybe via DHT or something like that, kind of greedily or in some other aspect, try to find other nodes and kind of connect to the best ones. If you know, like in BitTorrent, for example, kind of a similar model. So you will be downloading a torrent and your client will be trying to find other clients which are kind of good peers for you, from which you get a good download speed. Something similar could be used here. The fear is that if we go with that model is that it becomes sort of a kind of everyone locally optimizing doesn't necessarily bring like a good global setting for the network. So we're still kind of talking and debating these two models. That thing. Stuart asks, is everything written in Node.js right now? Yeah, currently it's written in Node.js. It's been a good tool definitely for kind of getting stuff started as kind of like a prototyping. We have had quite good experience with the Node.js. There's just some things that might be maybe better in some languages, but I guess it would be good to have like implementations in many languages and instead of kind of committing into one. So we have also talked about like Golang as a possible option for writing a node. Is implemented a security measure? Ibrahim asked, is there a security measure to protect double selling? So what I'm assuming is sort of you mean like someone's gonna subscribe to the data and kind of resell it in that way. Let's go with the obvious thing. Like the obvious thing is that you're kind of act as a node and you try to kind of listen to data. So not even this fancy model. That will be handled via encryption. So there will be encryption from kind of the publisher, the seller of the data to the buyers of the data. So the data will kind of go encrypted within the network. The nodes will not be able to see what the data is. They will just propagate the data. The nodes need some metadata so they can act kind of, they need to know the stream ID and that sort of stuff, but they can propagate the data without having to see the contents, right? So the encryption mechanism will be kind of more maybe related to the marketplace where kind of sellers and buyers meet and everyone who buys the data gets a key to the data, and that there's some key rotation mechanism, which I'm not kind of that expert in, but Melchior from our team, he's kind of involved in the encryption thing and rotating keys. There's some interesting stuff happening there. Another thing, I guess, is like just a more maybe simple way. In one way, it's just, okay, I'll buy a stream, I'll subscribe to it, and then I'll resell it because I'm a valid buyer of the data. I can basically resell the data, and that's kind of that's a tough one to kind of completely crack. There's things like in our key mechanism system, like if we detect, we can do some kind of things where if we kind of have a guess on who the buyer who is kind of leaking the data or reselling is, we can kind of cut them off with the encryption scheme. But it does require some kind of it's kind of technically kind of a hard thing, but that's one way. But that doesn't completely prevent it. Another one is just kind of having like this rating and credibility system. So probably for a lot of like people, it's important to kind of get the data from a reliable source. So if I'm doing, say, trading, I'd rather buy my data from a reliable source than an unreliable, because the unreliable source could basically do something, change the numbers a bit and make my trading bot do something incredibly horrible for me. So in some sense, having like the possibility for in our marketplace, for this is going a bit in the marketplace section, but having this kind of rating system and this kind of data provenance there, I think sort of fixes that. But it is a hard question, and it is a hard problem to solve, this security of double selling. Another question from Ibrahim. Is there a plan for migrating from Kafka to another solution for storing data? Yeah, so about that. So we got rid of Kafka. We don't have Kafka anymore, but now we have the Cassandra, Apache Cassandra. And we have made the software architecture so that it is possible to use other storage solutions than Apache Cassandra. What we've learned of Apache Cassandra is that it's quite a heavy piece of software. So running it is takes a lot of resources. On the other hand, it has good performance when you start getting into those big numbers. So it's kind of like this. It's very good for those very high data kind of scenarios, but not necessarily good in situations where you have like commodity like hardware, maybe lower commodity hardware, and you're doing kind of only subscribing to a couple slow streams. Then Cassandra is kind of like an overblown thing. So in our network kind of architecture, let me share the browser again here. We have here on the broker layer, yeah, we have this interface storage, and it basically we can make different implementations of it for different storage solutions. Let's see. I guess another interesting thing for if we think about decentralized storage solutions would be to kind of look into some of these time series storage solutions. I'm not that aware if those sort of systems are developed. Are there projects developing those? But those would be interesting to look into. I know there's like SQL type things, but what we really are looking at is like time series. Storing time series data in a way. So Wei has a question, curiosity. Can a company in the future offer tracker node as a service potentially for Streamr? Can a company in the future offer tracker node? See if I understand. So you're basically saying that, are you like asking like if there's like this high, like trusted company or something, or organization kind of providing the tracker service and selling that sort of, or you just make this like trade-off?
Yes.
Yeah.
Also, like if you can also read the question out loud, because in the video recording, people that want to rewatch later might not see the chat. Like.
Okay. Yeah. So the question, can a company in the future offer tracker node as a service, potentially for Streamr Network? So users might decide on trade-off between efficiency and decentralization. Yeah, it depends on the model we go with, right? So if we go with a model where you have these trackers and they're in the prominent role, then you need to kind of choose a tracker. So one model could be that the stream itself has a setting of what trackers it trusts. So you give it a list of trackers that you kind of trust, and then you use those trackers. Another thing worth thinking about is maybe these trackers are not as much forming the network, but kind of information providers. So you could think of the tracker being someone who is collecting information about the entire state of the kind of global network, and maybe it can provide hints to these network nodes, and the network nodes then can kind of decide which trackers give out good information and good predictions, and which ones don't give out some good predictions, and have some kind of slider, maybe, you know, how much do I want to trust the tracker versus how much do I want to make decisions on my own. But in the end, it's up to the nodes themselves to kind of, in some way, decide who they connect or disconnect to, I guess, unless there's some kind of incentivization mechanisms in place to kind of do it otherwise. Stuart is asking, I believe you can run a smart contract on Ethereum on a Streamr event. If I wanted to target another blockchain, could I write a plugin for that? Would that be implemented in the node? I believe you can, don't know if I fully understand if I want. So in the current network, I'm wondering if you're asking kind of about the UI, the core product we have.
Yeah,
in the network.
I think he's asking about the Ethereum modules on there.
Yeah, it is. You could make extendable, extending that to kind of like other blockchains and other smart contract systems. Currently, we have only the Ethereum thing there, but it could kind of be made in a similar model. If you look at our code base, maybe I can go a bit more concrete actually on this question. You can show it here. Streamr Dev, we have an engine editor. So this is kind of the UI, the editor UI you're used to seeing. So there's, if you go to source, let me see, Java.com, we have here a lot of like some of our modules, which you see on the canvas, like, so a very simple one, if you want to kind of, if you're interested in this, I don't know, but just why not? The sum module is very simple. You can start kind of reading through these modules and seeing how they're done. Actually, the most simple one is probably the add module. Can I find it right now? Here. Yes. Actually, yeah, they're under this path here. So here you can then find all the modules, simple math. So for example, divide is very simple. You can see it here. We have inputs. These are the inputs you see. We have an output. We have this anything, and then we just check that it's not 0. And put this. The Ethereum models are, of course, a bit more involved. You can also find them under here, under blockchain. We have some modules here. But yeah, we have also been internally thinking about adding some other smart contract platforms there, but I'm not so day-to-day involved in this side of the thing that I'm not that up to date with that. Let me see, where did my chat window go? Up here.
Yeah, I guess just to add to that one, I think as Eric mentioned, the module is not really like a blockchain like locked in that sense. They're just actually querying data from APIs, and we're using Infura, I guess, for the Ethereum currently. So
yeah.
If you have like, API providers for other blockchain, or if you're running a blockchain and then you offer those services, would be not too hard to integrate new blockchains into the core app, which is the visual editor and engine behind that.
And just quickly about the network, like we of course, we're planning on using Ethereum there, but in a very light way. So we're not building all of this very heavily on top of Ethereum, but we're using Ethereum for the value transfers, of course, data tokens for buying and selling data, but then also for identity and keys and that sort of stuff, and the marketplace. So, but we could use another platform if we desired so, but currently Ethereum does the job pretty well, I'd say. So where does the module execute on the node? So yeah, currently it's not in these network nodes, what I was showing. They don't actually run these canvases. They just do the data, kind of the data transfer. So in a canvas, for example, when you're subscribed to a stream and you're doing something, you'll get it out of the network. And then when you publish something from a canvas, it'll go back into the network. So it's a sort of a separate thing in a way. You can use the network without the engine editor if you want, or you can use it with the engine editor. With engine editor, I mean canvases, to be perfect. But currently, it's kind of like a cloud service where they're being run. currently.
Yeah, I think to add, I guess, to that one, there was some talk regarding like, potential kind of a decentralized computing engine or like, service down the milestone. But that would not be, I guess, for the next release, but way down the road. And I personally met a few projects that are trying to tackle that side too, in terms like, decentralized computation on demand. So there might be like, collaboration partnership, or we might deploy internally, but still TBD from Streamr point of view, I guess. That would be the answer.
Yeah, we're keeping our eyes out on the developments on that field. Like, well, how does this decentralized running of arbitrary code? Well, that seems to be a kind of a hard problem currently. But then I guess there's kind of venues into kind of running less arbitrary code, maybe decentrally, and maybe there's some fruit that comes out of those kind of research paths, but we'll have to see what happens there.
Eric, I have a question for you regarding the incentive layer.
Yes.
How we are, right now we're planning to, of course, use Ethereum. Would that be any scenario, or like in the future plan, to allow nodes to use different type of blockchain networks at the same time?
It definitely could be possible. I mean, it's all open source in a way, so you could go there and basically edit it. Do you mean like
coexist, like
would these nodes be interoperable when they're working on different blockchains? That's an interesting topic. Yeah, I don't know if I have like a definite answer for that question. Like, one thing that is important is the identity here of the nodes. So each node will have like an Ethereum wallet attached to them. Not in this current version I showed, but kind of in further versions. So yeah, it would be kind of, I guess the difficulty would be coming from the interoperability. So if you have one node that's based on Ethereum and another node working, how do you value transfer between those? And then you'd need some of these kind of solutions where you kind of can do stuff between different blockchains. So, but that's quite far probably in the future.
I definitely get asked a lot about that question. So we can, I guess we just leave it open-ended and
The Spectrum can write data for $0.001 to a custom chain. That's why I was asking, as I wondered if I could write my own plugin. Yeah, I mean, we have to, I think we'd definitely be interested in contributions to the engine editor, but definitely we could help out with kind of getting started with it, because the documentation in that project, I think, let's check where it is. There's a bit kind of, there's a lot of code here and kind of maybe some reading required. Yeah. You're interested in creating some kind of plugins, I think maybe somehow kind of contact details for how to kind of technical support on that end. I was thinking I might write one maybe. Yeah. There's something in the current, I think the current Ethereum thing, like listening to events and then executing some canvas logic based on that. there any other questions? We still have like, I guess, 4 minutes or something.
I guess let me throw a question out there. If someone is interested in contributing in any of those different like technology stack, right, whether it's network or the engine editor, if they want to customize some modules, like run their own, what would be the best way to approach?
I think probably let me check. Let me open a repository here, for example. So I have here a repository. That is a bit of a new thing for us, to be honest. We have had some contributions to some projects a while ago. I would kind of maybe send us a mail, for example, Eric, just my first name, Eric @streamr.com, and ask like about a feature, and would it be like interesting to add to the code base. One thing is, of course, probably we kind of want to keep it relevant to kind of the project goals in a way. So if someone is writing a plugin for a network for a virtual toaster or a water plant graphic thing, maybe that's the most interesting for the goals. But also, so like, for example, in this network project, what would be very interesting is these adapters. So I was talking about the MQTT adapter. So if you have some like device that's producing MQTT, you can now kind of plug and play, just add it to the network and have it be accessible to a stream in Streamr. So these adapters would be an easy way to kind of extend if there's some weird protocols you're aware of. Like there's all sorts of protocols in the world. Those, and then these storage nodes. Someone was asking like about the Kafka Cassandra. Like, does it have to be that? Well, it doesn't have to be that. We can also use something different there. So those are the things I can think about that are easy to extend. So then right off the bat, let's check. There's some questions in chat. Just discussion. Okay, interesting. C#. Oh, okay, that's interesting. Yes, definitely. Yeah.
Erica, would you mind passing the host?
Yes. Let me.
Actually, I can do it.
Okay, good.
Okay, perfect. So thank you everyone again for coming and joining us in this webinar. We will be, I will have been recording this video webinar, so we'll be sharing the link soon after it is being processed. Feel free to share with our friends, other people that might be interested. Before we leave, I guess just a few final quick reminder is where you can find, I guess, additional information on Streamr. The first one, of course, our main website, Streamr.network, where you can see, the documentation and especially try out the core editor, Streamr canvases, dashboards, etc. And for developers, feel free to go to our GitHub. You can see all the repository for all our different tech layers, stacks. And then finally, we have a forum dedicated to developers, forum.streamr.dev, where you can ask about technical questions, integrations. We have also actually a community fund where you can propose projects for technical integration, pilots, and demos. So, for example, we have Stuart that was working on an interesting, I guess, C# project with Streamr. So, if you're interested, feel free to, shoot us an email or post on the forum. That's it from my side. And anything else, Eric?
Yeah, thank you for coming. Thank you for participating. I hope you got everyone got something out of it, learned something new. Bit technical, but yeah, interesting stuff. And next features we're working on, it becomes even more interesting. So it's a lot of, we have the incentivization at some point, and then we have the security thing, security vectors, attack vectors, protecting against those. Yeah, interesting stuff incoming.
Okay, thank you all. I'll be ending the meeting now.